Recording started.
All right. Good morning, guys. I remember many a college exams going that way where they have to be graded on a curve because they're just that difficult. So, um, yeah, good luck with that. I mean, well, not good luck with that, but you'll have to let us know how you did if you got a record high or not once you get those results. um, as far as today goes, I have a couple options for you guys today. I know that Unit 5 is starting off a little bit rough with those identities. They're really tricky. They take many hours sometimes to look at and do. We have a little bit of flexibility here in the last unit. Obviously, we can still move forward and we can look at 5.03 today if you'd like. But I was looking at what we have left for the rest of the year, and we can push things back if we need to. So, what would you like to do today? Would you like to review 5.01 and 5.02? We can look at questions from the book and work through those. If any of the homework questions are stumping you, we can look at that. Or do you guys feel good with those identities and you want to move forward and look at 5.03? So let's get your opinions on the matter and see what you guys would like to do today. Okay, if you'd like to review today, that's totally fine with me. I will just kind of rearrange our calendar a little bit then for the rest of the semester. Okay. We'll use today as a review day. That's totally fine. So what we'll do is I'll push things back just a little bit. So next week we'll take a look at 5.03 on Tuesday's class. 5.04 I was going to use as a free day, but we'll circle back to that Thursday. Next Thursday I was going to use as a free day, but maybe we'll circle back to 5.04 at that time. Or I'm going to take a look to see how things are adjusted. We might be able just to push 5.04 back until after winter break because there's only like 5 or 6 lessons in Unit 5 and we're hitting that halfway mark already. And it's the last unit we're going to look at for this semester. So I'll play around a little bit after class today with reorganizing things so that we can do a review day today instead. All right, if we're going to do a review day, we need some problems to review. So let's open up our books. If we want to start with 5.01, we can. 5.01 was that simplifying piece, and they solved a little bit of them. I guess let's start with the homework assignment maybe from there. Yeah, let's start with questions from 5.01, whether they're from the book, or the homework assignment. So just let me know where I need to be looking to pull that question and put it on the board. So if you have anything you'd like to start off with, go ahead and throw it in that chat box. Yeah, go ahead.
All right. So, I remember you should remember that I asked you for directions on question number 31
Mm-hmm.
in the book for the practice problems. I took a look at the thing and I'm kind of confused on where the last sine x went in terms of like when you turned everything in and you went from step sine 3x plus sine x times cosine squared x all over cosine x, and you turn that into just sine x equals sine x or sine squared x plus cosine squared x, and then all over cosine. I'm wondering how that works because I don't see how sine cubed plus sine x times cosine squared can be rearranged into just what looks like 3 sines rather than I'm just kind of lost on
Okay.
what transition is.
Yeah, let's just work through the problem from start to beginning because the rest of the class hasn't seen those steps that I sent you. So we're just going to start from the very beginning. So this is question number 31 from 5.01 in the book. Is one of the practice questions for you to try before you got to your homework assignment. And it basically just said to simplify this. All right, if you were looking at the answer in the back, it did give you the answer that this is going to simplify down to tangent of x. So we got to kind of figure out how to get there. What are your first initial thoughts when you see this problem and you need to simplify? So what are some of those strategies that we covered? Yeah, let's convert things to, and not just tangent, but maybe everything to sine and cosine. So we can maybe start with that. So tangent is going to be, I'll work horizontally, I guess, because I think I'm going to need the room. Sine over cosine. What about the cosecant squared right here? Cosecant squared x, what is that this going to convert to? 1 over is cosecant sine or cosine? Sine, good. Now it is going to be squared, right? Because cosecant is squared here, so we want to leave that squared. Good. Plus tangent again was sine x over cosine x divided by, now secant squared. If cosecant was sine, secant squared, remember that's your cosine. Sorry to steal your thunder, guys. All right, any ideas for me at this point? So now we're in blue. What can we do from at that step to simplify it further? Yeah, I don't like the dividing of the fractions there. So if we can simplify each piece here, that's going to help us. So because we can't divide fractions, we have to change this into a multiplication problem. When we change that into multiplication, we take the reciprocal of that second fraction. Okay, let's see what we get for the second one. So sine x, cosine x, cosine squared x. All right, now normally my first instinct would be to try to simplify anything from the numerator with the denominator, but I'm going to hold off on that because I do have adding fractions here. And if I'm going to add fractions, I want a common denominator. And I have that right now. We're sitting at that cosine x times 1 in both fractions. So we got the common denominator. So I'm simply going to rewrite this with that common denominator instead of having the addition sign. Separating them. So that's going to be a sine x, sine cubed x technically, plus a sine x times cosine squared x. All right, now what can we do in that numerator to try to simplify things? So what are some of the strategies we talked about once we get to this point and we're trying to simplify in that numerator? Factoring. Yep, you're going to look for a GCF because we're hoping that maybe we can factor something out, and if anything, maybe it'll simplify with the denominator. If that's not the case, if we can still pull out the GCF to use factoring, maybe what's left over then, once I pull out the GCF, we can use the Pythagorean identity with. So those are kind of my two options that I'm hoping is going to happen here, or at least one of them is going to happen. All right, so if we take out the GCF of sine x in this numerator, that leaves us with a sine squared x plus cosine squared x, and hopefully some light bulbs are going off there. Yep, that's 1. That's our most common Pythagorean identity, right? That's the one that we'll have implanted in our brain for all time. because that does simplify just to a 1 in here, sine x times 1 is just that sine x. And finally, sine over cosine, which trig identity is that? Our tangent. Ta-da! Wonderful. All right, so lots of good strategies there. Yeah, we did have to factor when we got to that orange piece. Exactly. Yep. Awesome. So lots of good strategies all in one for that one. All right, were there any other ones from 5.01? Did you guys want to take a look at that last question with the solving? I think there was a lot of confusion with that last question where it asks you to solve. I want to pull it up though exactly here, see what it was. This one, a lot of people were really struggling with the last one or just the solving pieces in general, where it said find all the solutions on that interval from 0 to 2 pi. All right, we didn't really talk about the solving piece too much in the live classes, which is I think why we struggled with it a little bit more when we got to that homework assignment. But think about solving it the same way you would if this was a normal equation and you didn't have any trig involved. So if you didn't have any trig involved, how would you go about solving an equation? Well, hopefully the first thing that comes to mind is that everything has to be on the same side of your equal sign because you want it to equal 0 so that hopefully at some point you can start putting pieces equal to 0 and working backwards. So knowing that, we've got to move the sine x to the other side. How do we move the sine x to the other side? Yep, we're going to subtract it. All right, then what would you try to do from here? Sure, we can do that. Let's see, sine, if we're changing it to sine and cosine. Okay, then what? And sometimes when we do things, we may hit a dead end and we're not exactly sure what to do from this point. And maybe we've reached that. We're like, okay, maybe I've made this more complicated than it needs to be. Sometimes that happens. It happens to the best of us, and especially at the beginning here, we're like, uh-oh, now what? So maybe if that didn't work and we can't really visualize what to do next, we go back to the blue and we see if there's a different strategy we can try. Instead of converting to sine and cosine with tangent, is there a different strategy we could try back at the blue step? Factoring out the GCF. Okay, so I am going to, you could also do that with the green we just did, but I'm going to backtrack a little bit here and go back to the blue and take out the sine of x. Okay, if I take that out, I have tangent squared x. Yep, exactly. And that's okay. We live and learn, right? So if we do get stuck along the way, it's all right to go back to an earlier step and start over. Because there are multiple ways that you maybe can solve this. All right, so we backtracked a little bit. We took out the sine x, and we're left with tangent squared x minus 1 inside those parentheses. Anything else come to mind once we do that? I do see a squared and I do see a 1, so that might set off a Pythagorean identity somewhere. Negative secant squared. Does anybody want to verify the negative secant squared? I definitely think it's secant. I can't remember if it's negative or not. It might be. Let me just look in the book real fast. Okay, yep, I think it is going to be a negative secant squared. All right, any ideas from here then? Are we far enough along that we can try to set each piece equal to 0? Yeah, I think we can. So let's go ahead and do that. So each piece that has a variable, and there's two of them, sine of x and negative secant squared x, and we might backtrack a little bit even more. I may go back to the green when we get to that secant squared part, that negative secant squared part. So we may actually backtrack a little bit there, but we're going to start with the yellow, that sine of x. So this is a piece that I think a lot of people missed when they got to their homework question and they had to solve it then. So I think we are okay with the negative secant squared x part, but we missed this first half. So we want to make sure we set this sine of x equal to 0 and solve. Now you do need your unit circle to figure this out. Where does sine equal 0 on your unit circle? 0 and, does it equal at pi as well? All right, now let's go ahead and figure out that second piece. So let's go ahead and take the negative secant squared x, set that equal to 0, and we'll solve. And here is where I think it might be easier to actually backtrack to the step before it and just take that tangent squared x minus 1 and set that equal to 0 and solve. We could set this up as a negative 1 over cosine squared x equals 0, but we can't, I don't know, it doesn't settle well with me when I look at that and try to solve that. So I think it's easiest if we actually backtrack it back to that tealish green and we take the tangent squared x and minus 1 and set that equal to 0 and try to work backwards and use tangent instead of 1 over cosine. So let's do that. I think we'll have better results with that. So let's go ahead. How would I isolate that tangent squared x in that setup? Adding 1, good. And I do want to get rid of the squared as well. Yeah, so I'm going to take the square root of both sides. Now when I take the square root of both sides, I do have to put a plus or minus out in front of the square root sign. All right, and I actually think this one's a little bit nicer to solve using your unit circle. So where does tangent equal a positive 1 and where does tangent equal a negative 1 on your unit circle? So in order for tangent to be 1, remember the x and the y coordinates have to be the same. Awesome. So I'm just going to move this over slightly. I'll put it up here more. So I'm going to add to my answers then. So pi over 4. And looks like 5 pi over 4. That's probably where they equal maybe the positive one, and then the negative ones, and I don't have it in front of me. Yeah, 3 pi over 4 and 7 pi over 4. So it looks like there may be 6 different solutions that are going to work for this equation. Now notice that we did keep our answers between 0 and 2 pi, and I am putting 0 in for my solution set because there's a bracket up here in my interval. So brackets mean that that number is included. So we want 0 as part of our answer. Okay. Any questions with how we solved that at all? All right, let's take a look at another solution one. Do you guys want to look at 7 or 8 from question or from 5.01? So question 7 or question 8? Do you guys have a preference? 8 it is. All right. After this one, then we'll jump over to 5.02 and we'll look at our proofs and see if anybody is stuck with any of those questions, and hopefully we can work through a couple proofs today as well. All right, so it says find all the solutions on the interval from 0 to 2 pi. Notice 2 pi has a parentheses next to it. That means we do not want to include 2 pi in our answer. All right, so it's strictly, you can include 0, but not the 2 pi. So it doesn't want you to hit that point twice. All right, so find all the solutions here. Eek! Any ideas on how we can even begin this? Try factoring. Yeah. Now, if you're really struggling with the factoring, I would maybe take out the trig and write it with just your variables. So I might actually look at that as a 7x cubed minus a 21x. As long as the trig is the same with these, I might just take it out for right now. See if I can look at that using just my variables of the x cubed and the x, and if I can factor it using that, then I can throw the tangent back in front of the x once it's all factored, said and done. So when I look at 7x cubed minus 21x, how do we factor that? You can take out a 7x. All right, so if I take out a 7x, what's left inside my parentheses? X squared minus 3. Okay. Now, I'm going to go ahead and put tangent back in front of that variable again. So 7 times tangent of x times tangent squared x minus 3. Okay. It looks like we got it pretty good. Let's go ahead and try to set each part equal to 0 and solve then. So we'll start with that first GCF that we took out, the 7 times tangent of x equals 0. How are we going to go about solving this one? Divide by 7. Yep. Because we got that tangent by itself. When we divide by 7, it still stays a 0, because 0 divided by 7 is 0. And now we're to that point where we can bring out our unit circle and start looking for places where tangent is going to equal 0. So anybody find any spots where tangent equals 0? Look at all them spaces. Okay, there should only be 2. So we have to narrow down. Remember, tangent is sine over cosine. And the only way we'll get it to equal 0 is if the top number is 0. If cosine is 0, then it's undefined, and we got a whole another issue that's happening, right? So we're actually looking for where sine of x is going to be 0. So sine of x is 0 at pi and 2 pi, it looks like. So 0 and pi. Okay, so 0 and pi. 0 and pi, because 2 pi is the same as 0. So there are at least 2 answers that we will want, and it's really hard to see which one of those is going to be narrowed down. I don't see a pi in that first choice, and I don't see a pi in the second choice, but here it is there, and here it is here, and here, and here. Okay, so it's in the last 2, so we're good to go. We've at least got it narrowed down to one of the last 2 choices. Now let's go ahead and take a look at that other parentheses and see if we can solve that now. So we're coming back to the tangent squared x minus 3 equals 0. How are we going to solve for tangent there? Add the 3. Yay! There's one last step, though, to get tangent by itself. Because right now you're sitting at tangent squared. You got to square root it. So plus or minus the square root of 3, though. So anytime you square root it, don't forget the plus or minus out in front. This is a little bit more tricky, so we've got to be careful with the simplification process here. But where does tangent x equal a positive square root 3? And where does tangent x equal a negative square root 3? And you probably can actually narrow down your choices looking at the 2 that are left and identify which one's going to be the correct answer. So I see pi over 3 in both of my responses. When I look at pi over 3 on the unit circle, that is your 1/2 and square root 3 over 2. So we're looking for points where those are both positive or you have one of each, basically, because you can also be looking for the negative version of that as well. When you simplify that, remember tangent is sine over cosine, so that would be the square root of 3 over 2 over 1/2. Notice that those 2's cancel, and you do get just the square root of 3, so that is the correct points that we should be looking for, the 1/2 and square root 3 over 2. So definitely at pi over 3, but where else does that point occur at? Four pi over 3. Yep. Anywhere else? 2 pi over 3. Yep, because you got 1 positive, 1 negative. That gives you the negative version of it. And what was the last one? Was it the 5 pi over 3? Thanks. So you should get 4 answers here, right? 2 of those answers are going to give you the positive square root 3, and 2 of those answers are going to give you the negative square root 3. So we do want to go with this option right here, choice 3. All right. Questions with that solving piece. So those are tricky. What I need you to look out for with these solving ones is if you have the squared with the tangent involved, don't forget you have to take the square root. Anytime you take the square root, you must do a plus or minus. So you're basically kind of doubling your amount of answers because you're looking for the positive ratio of those and the negative side of it as well. So keep an eye out for those square roots where you have a plus or minus then. Okay, let's jump over to 5.02. Any major questions with 5.02? They will be, yeah. So they'll be kind of opposite each other on your unit circle, those positive and negative ones. Yeah, they'll kind of make like an X almost. All right, so any questions from 5.02? So 5.02 is nice and problematic at the same time. It's nice in that you know where you need to end. It's problematic because you don't know how to simplify to get there. So any questions from 5.02? I can take them from the homework if there's one that looks super complicated from the homework, or we can take it from the practice problems. Has anybody had a chance to look at them? Okay. If we can't find it, we can always just open the assignment and you guys can pick a problem too. There's what, 5 of them, I think? So you can just pick one of them that you think looks pretty complicated and we can try to struggle through that together. If you can't find a practice problem you want to look at too. No, struggling, okay, and I just want to point this out. Struggling is normal with these. So don't feel like you are alone if you really struggle with these. It takes a lot of time to train your brain on what to look for. How about you guys open the homework assignment and then pick a question 1 through 5? I sure hope that you plan on going into a science field after high school, Isaias. Ah, you're just wasting all of that potential there. No, I shouldn't say it. You're not wasting anything. Just maybe you're missing your calling. Okay, well, that's still, well, That's more math based than I guess science based. Awesome. All right. Any on the homework stand out that you're like, oh my gosh, I wouldn't even know where to begin if I had to attempt this on my own? Any of the first three. All right. How about. Well, let's just start with question one then. The beginning is always a nice place to start, right? All right, so if you open up that homework assignment or that quiz, remember quizzes aren't timed, so you can open these and stare at it as long as you'd like before you have to hit submit. The tests are the only things that are timed. So if you want to open that now, even though you have no intention of finishing it today, that's okay. You can do that. You can always come back to it. All right, any ideas on how we can maybe begin to prove this? Like which side would you maybe want to start with? The right hand side? Okay, we could start with the right hand side. Any ideas what we could do with the right hand side? Okay. Let's see if that gets us anywhere. If it doesn't, remember we can always come back and start with the left hand side, or see if we can find a common middle ground, right? So we'll change these to sine and cosine. I believe that's going to be a cosine x over a sine x plus 2 sine x over cosine x plus sine cubed over cosine cubed. All right. Then what? A common denominator, okay. What is going to be our common denominator? Like, what should we multiply the first fraction by? Maybe I should ask that instead. We'll go piece by piece. What's the first fraction missing that the other ones have? A cosine cubed. Okay, we'll go piece by piece. It's easier that way, right? Sometimes. What about the middle one? Cosine squared and a sine. So because it is, I'm just going to put that squared on the sine to represent what that one was missing. And I'll change that to a cubed on the bottom. All right, and then the last one. So let's change this to a 4. Okay, so I'm going to rewrite this now so that we have sine x cosine cubed x in the denominator. We have a cosine to the 4th x plus 2 sine squared x cosine squared x plus sine to the 4th. All right, any ideas where we can go from here? I have one, but we'll see if what you guys want to do, what you're thinking. Okay, I'm not sure. I'm thinking factoring as well. I'm thinking we may want to try to factor instead of using a trig identity. I do think a trig identity may come into play. Let's see what happens if we can maybe factor it instead and then look for a trig identity. Because factoring might allow us to break it down and then replace with the trig identity if we can break it down to the squared level at least. All right, is that a perfect square trinomial? It very may well be. Let's see. Maybe we can break it down into a cosine squared x plus sine squared x. Is that gonna work? If we do it like that? I think so. I think it will. I think that's a perfect square trinomial in the numerator there. It should, right? All right, now what do we notice about those? Yeah, if you FOIL it real quick, what do we get there? Not a 2. You can replace each parentheses with what? You can use the Pythagorean identities. A 1. Yeah, so technically you're going to get a 1 times 1, not a 1 plus 1. So a 1 times 1 is just a 1 in the numerator. We're close. We actually have to do a kind of a crazy step at this point. We're almost there though, almost to getting to this final point of cotangent x times secant to the fourth x. I only got, first of all, I have a sine here, and then I got a cosine cubed. If I could get that to be a cosine to the fourth, we'd almost be golden. So what do you think we should do to try to make this a cosine to the fourth power instead of just a cosine cubed? You're going to multiply by a cosine over cosine. That's exactly what we want to do. And I ran out of space, so I'm just going to come back up over here. If we multiply both the numerator and the denominator by a cosine, that's technically by multiplying like a 1, right? But it allows us to get the appropriate exponents now. And it also allows us to break this up, because now I can break this up as cosine x over sine x times 1 over cosine to the fourth x. So now we can kind of break apart that sine x and cosine to the fourth x in that denominator there. So we can kind of see this taking shape. Cosine over sine is our cotangent, and 1 over cosine to the fourth is our secant to the fourth. Yay! And that's what we wanted to end at, right? We wanted to stop there. All right, awesome. And by the way, when you type this in into your homework, because all of these obviously are essay type questions and show your work because you have to actually show the steps to simplify for these. If you want to do your work on a piece of paper and take a picture, right, you can do that. So I know that it's a lot easier to just do it by hand on a piece of paper and turn that in than having to type it all out on the computer. So if that works better for you, if you want to do it in Google Draw, that works for me. Just make sure you put the link into the text box area or a picture into that text box area so I can see that being done. So I am looking for all the steps there. I got a little bit off topic. When you turn the assignment in, the answer looks actually a little bit different than we did because I started with the left-hand side and not the right-hand side. So I actually chose the left-hand side to simplify versus the right. But it's okay to do that right-hand side, obviously, because we got there in the end. Okay, we've kind of hit the end of our class as well. So take a look at these identities some more, these proofs for 5.02. They're going to be a little bit tricky. So if you guys want to shoot emails back and forth to each other or start like a study group or whatever, feel free to do so. I know that you guys probably run into each other quite often in some of your other classes. So if you want to do like study buddy groups, go for it. Otherwise, I'm in office hours as well to help you through or at least get you kind of started with some of them. So if you do need me, let me know. Okay, because they can be pretty tricky. Any questions with what we reviewed today? So I will rearrange our calendar and rearrange kind of those homework assignments and when they're due and push things back a little bit. So just kind of keep an eye out for that with some of those due dates changing, but they're for the better, right? They're going to be pushed back versus moved forward. So hopefully you guys will have some little extra time to work on these. All right, then that's all I got for you guys, so I'll let you go. Have a great weekend, and we'll start with any questions you have with these on Tuesday as well, but we'll plan on looking at 5.03 on Tuesday. All right, bye guys. Have a great day.